Okay, so the number of houses sold by an estate agent follows a Poisson distribution with a mean of 2 per week. Part A asks us to find the probability that in the next 4 weeks the estate agent sells. So, what we know at the beginning is for 1 week, if X is the number of houses sold, then X is distributed with a Poisson and with a mean of 2 per week. So over 4 weeks, that means that it will still be distributed with a Poisson distribution, but we will expect 4 times as many house sales, so we're going to have a Poisson mean of 8. Now, part I wants us to find the probability of selling exactly 3 houses. So whenever it's got a probability of exactly of any value, I tend to use the formula. It's just good practice. You can use the tables, but remember that occasionally some questions will specify that you do not use the table, so you need to be familiar with using the formula. So it's good to practice it and the opportunities that you get to practice it. So the probability that X is equal to 3 is equal to e to the power of minus lambda, so minus the mean, which is 8, times by lambda, which is the mean, to the power of x, which is 3, all over x, which is 3 factorial. So, when I type this into my calculator and process it, what we get is an answer of 0.0286 to 4 decimal places. Okay, so how do we get marks so far in this question? Well, initially we get a statement mark for stating the correct distribution over the 4 weeks, that is the X's distribution with a Poisson distribution with mean 8. We then get a method mark for demonstrating our use of the Poisson formula, and we then get an accuracy mark for a correctly rounded answer to 0.0286. Okay, so let's have a look at part 2. Now, we're then asked to find the probability that more than 5 houses are sold. So we're looking to do the probability X is greater than 5. So in other words, I'm talking about doing probability X is 6, 7, 8, 9, 10. So what that means is I'm going to have to do, that's going to be the far end tail, so I can only do less than or equal to a value. So what I'm going to do is I'm going to do 1, the whole probability, take away the probability that actually we sell less than or equal to 5 houses. And so I then go and look up this value, probability X is less than or equal to 5, in tables. In this question, we are looking to find the probability X is less than or equal to 5 with a Poisson mean of 8. So we're interested in this column here. Look across the top row for the Poisson mean. What I'm going to do is I'm just going to quickly rule a line down the side here so we can see which column we're dealing with. Okay, now when you do this, you should be using a ruler and just holding it to the side, or perhaps a piece of paper just to the right hand side to line it up and make sure that you don't come across the columns by mistake. Now, probability X is less than or equal to 5, so we're looking around about this mark. Again, just going to rule across so we can see where we're taking the reading from. Again, use a piece of paper or a ruler, and you can see that the reading we are looking to take here is in this bottom right corner of 0.1912. Having found our value from the tables, now that's all left to do is to carry out our subtraction. So I get 1 minus 0.1912, and so this then gives me a value of 0.8088. Okay, so how do we get the marks in this second part? Well, first of all, we get a method mark for correctly identifying that we would need to do 1 minus the probability of X is less than or equal to 5, and then we get an accuracy mark for getting our final answer of 0.8088. Okay, so let's have a look at part B. Part B says the estate agent monitors the sales in periods of 4 weeks. Find the probability that in the next 12 of those 4-week periods, there are exactly 9 periods in which more than 5 houses are sold. Okay, so what's happening here is we are monitoring periods of time where either 5 houses are sold or 5 houses are not sold. So let's say Y is the number of periods Y is the number of periods that more than 5 houses are sold. Okay, so what we're having to do here is set up another distribution, because what we're looking at is the fact that either in this period the house is sold, more than 5 houses are sold, or they're not sold. So we're looking at a binomial distribution. So we have Y is distributed binomially, where we have 12 periods that we're looking at, and the probability of selling 5 or more houses is 0.8088 that we got in part 2. Okay, so what we're being asked actually, once we've got this distribution, and that's the main bulk of the work here, is identifying actually how we're going to do this. We then need to work out the probability that there are exactly 9 periods in which more than 5 houses are sold. So what I'm now asking is the probability that Y equals 9. Now again, you could use the tables here, but as I said with the Poisson formula, when you get the opportunity, just practice using the binomial formula. So I've got NCR, so I've got 12, choose 9. So this will calculate the number of different ways, different arrangements that we could actually sell 9, have 9 successful periods of time. Multiply it by the probability of success, which is 0.8088, to the power of the number of successes, which is 9, multiplied by the probability of a failure, which is 0.1912, which we calculated or read earlier from our Poisson table for a probability x is less than or equal to 5, and that's to the power of the number of failures, which is 3. So 9 plus 3 adds up to the 12 here. So when I put this in my calculator and I work it through, I get an answer of 0.228, correct to 3 decimal places. Okay, so how do we get our marks in this question? There are 3 marks in this question. First of all, you get a method mark for correctly stating that we have this new variable, let's call it Y, or whatever you want to call it, that's distributed binomially with the number of trials 12 and a mean of 0.8088. We then get a method mark for actually showing how we can substitute this into the binomial formula, and then finally we get an accuracy mark for the correct answer, 0.228. Okay, so I hope that all made sense and that you understood it.